Welcome to this tutorial on the axis parameter in NumPy aggregation functions. Understanding how to control the direction of aggregation operations is crucial for effective data analysis. The axis parameter allows you to specify whether you want to aggregate data across rows or columns, giving you precise control over your calculations. The axis parameter is a powerful tool that controls the direction along which an aggregation function operates on a NumPy array. Think of it as choosing whether to collapse rows or columns when performing calculations. When you apply an aggregation function, the axis parameter determines which dimension of your array gets reduced, fundamentally changing the shape and meaning of your results. In NumPy, arrays have numbered axes that determine the direction of operations. Axis 0 operates down the rows vertically, moving through each row from top to bottom. Axis 1 operates across the columns horizontally, moving from left to right through each column. Understanding this distinction is key to controlling how your aggregation functions process data. Let's create a sample array to demonstrate these concepts. We import NumPy as NP and create a two-dimensional array with 3 rows and 3 columns. The array contains values 1 through 9 arranged in a 3 by 3 grid. This array has a shape of 3, 3, giving us a perfect example to explore axis-based aggregations. When you call np.sum on an array without specifying an axis parameter, NumPy flattens the entire array and computes the sum of all elements. In our example, this means adding all 9 values together. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, which equals 45. This is the default behavior when no axis is specified. When we specify axis equals 0, the sum function operates down the rows, collapsing the vertical dimension. This means we add up all values in each column separately. The first column contains 1, 4, and 7, which sum to 12. The second column has 2, 5, and 8, totaling 15. The third column contains 3, 6, and 9, summing to 18. The result is a one-dimensional array with 3 values, 12, 15, and 18. When we set axis equals 1, the sum function operates across the columns, collapsing the horizontal dimension. This means we add up all values in each row separately. The first row contains 1, 2, and 3, which sum to 6. The second row has 4, 5, and 6, totaling 15. The third row contains 7, 8, and 9, summing to 24. The result is a one-dimensional array with 3 values, 6, 15, and 24. The axis parameter works consistently across all NumPy aggregation functions. np.sum calculates the total sum of values. np.mean computes the average value. np.max finds the maximum value, and np.min identifies the minimum value. Each of these functions accepts the axis parameter, allowing you to control the direction of aggregation for any statistical operation you need to perform.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.